There you go.
There you go, for real.
All right. Common denominator is 10. So you're going to multiply both sides by 10. And you'll get 5x equals, 5 goes into 10 two times, 2x plus 3. This is 5x equals 2x plus 6. Subtract 2x, subtract 2x. 3x equals 6. Divide by 3, and x is equal to 2. Okay? Any questions on that? All right. We're going to press pause again. We're going to check out my man Trey. All right, so let's take a look. We got to factor this piece. It's x minus 5, x minus 1. That shouldn't be a surprise. That's what showed up over here. That usually happens. If you haven't noticed that, you gotta take note of that. So when you do x minus 1, x minus 5, x minus 1, x minus 5, x minus 1, x minus 5. This x minus 1 cancels, leave me with 3, x minus 5. The x minus 5 cancels, leave me with 2x minus 1. Equals this, all cancel, 13. It was in parentheses. You didn't notice that? See it? All right. Word. 3x minus 15 plus 2x minus 2. I'm going to say it to my kids later on. All right. 5x minus 17 equals 13. 5x equals 30. X is equal to 6. Now, the one thing I haven't told you to do yet, and I was kind of waiting for just the right moment. There is no right moment, so I'm just going to tell you. You always have to check your answer when you get done. Make sure you don't get 0 in the denominator. You got 6 minus 1 is 5. 6 minus 5 is 1. That's good. You don't want to get 0 in the denominator. If that happens, you have a problem. Okay? Seek a counselor probably, but there might be a cream or something you can use when that problem exists. But you always plug it back in, and I haven't told you to do that yet, although I have been plugging it back in every single time. For every problem we've ever done, I've plugged it in and looked to see if it makes it 0. If it doesn't, I don't say anything. If it does, then I tell you it's no solution. But it may come up at some point that you need to worry about it. And as I tell students all the time, if you don't want to check it, don't worry about it, I will. Okay, I'll let you know. Hercules, what you got?
You went from the x squared minus 6 to minus 6x plus 5. Did you just multiply the top and the bottom by the common denominator?
Yep. Not the bottom. I didn't multiply the bottom by the common denominator. I multiplied through by the common denominator, and as a result of that, the denominators canceled. And so that's why the denominators are gone. Remember, common denominator does not always mean make them the same. It means that sometimes, but not always. They both cancel. Because they're both gone.
When is a regular number of top and bottom is like that, is the two denominators on the left side will be a factor of one on the right?
Are you saying is it? Can I answer typically?
Huh?
Typically? Most of the time?
Sure.
Most of the time it is. Is it guaranteed? No, it's not guaranteed. You're just not living right if it's not. The question that he asked, and it's a very good question. If you have a problem like this, where you say, 5 over x minus 2 plus 3 over x minus 1 equals 7x over x squared plus 8x plus 7. When you factor this, x plus 7, x plus 1, your common denominator is x minus 2, x minus 1, x plus 7, x plus 1. Your life just got a hell of a lot worse. And in fact, if I were working this problem, I swear to you, I am not even kidding. If I were working this problem, I'd skip it. No, I'm not even kidding. I would look at it and go, I don't need 100. I'll get 95. This is good. Because the amount of work that's going to be required to do this, you see, remember, when you multiply through by this, right, the x minus 2 is going to cancel, and you're going to get x minus 1, x plus 2, x plus 1, plus 3, and then the x minus 1 is going to cancel, and you're going to get all these pieces again, equals 7x. I mean, it's just going to be nasty.
So I guess basically what I'm saying is the two on the
You do it.
the two numbers on the left are going to be
Right now?
on the right.
Yeah.
Okay.
Go ahead, say it again.
The two denominators on the left will be a factor of what's on the right.
In most cases, yes.
Okay.
Or if it's not, it'll be something very close to it.
Okay. So for the relevancy of the test, what would it be?
Well, no, look, now you're trying to get me to be nailed down on something. I mean,
I'm just asking questions.
okay, the answer to the question, which was, on the test, will I guarantee that the ones on the left is the same on the right? I'm not guaranteeing anything. You know, if the Gators lose, then I get mad, and then I just take it out on you guys in the form of x minus 1, x plus 2, x plus 1. So, you know, good news for you is it's not football season, because if it were football season, the test could get real hard.
How you gonna pick out the shortcomings of your terrible team?
Oh, you would not be the first man to do that.
Well, because I get pissed off.
That's what you get for choosing that team.
I agree. Damn Urban. All right. we were good when he was here, jackass. But anyway, but does that make sense? I mean, I don't want to say always is, because I mean, you know, again, I mean, always is a really long time. But I would say to you, Hercules, that if what you do on the right side is not on the left side, it should at least cause and give some concern to you. And there's a good chance you screwed it up. But I don't want you to not to factor and just go like this. Well, hell, the right side always cancels the left side. I'm not saying that either.
Well, how it's looking now, what I would do is look like that.
Yeah, no, I agree. I know how it looks, but it's not always the case.
I would put the number over on the right side of the left.
Yeah, because what would you do if it were like this? 5 over x minus 4 plus 3 over x squared minus 16 equals 7 over x plus 4. What would you do then?
We have a factor that's square.
This is x plus 4, x minus 4. And then those two will cancel out because it's the same as the other two.
So I just did that. It wasn't nearly as grueling as you said it was.
Okay, did you solve it?
Solve for x?
Yeah.
Not quite yet, no.
Well, yeah, go ahead. You get an x cubed in there, don't you?
Chill it out. You get an x squared.
Should get an x cubed, I think. And good luck solving x cubed. Do you know how to do it?
No, wait, you do get an x squared, not an x cubed, because you got 7x.
You're going to get,
Well, not if you divide it by that, you only get an x squared.
you're going to get, just trust me on this. I mean, I've been doing math for like, so moving on. Hey, look.
Straight front, you spit over there. I'm sorry.
The x minus 5 appeared to just out of the blue. And we're multiplying through by x minus 5. So here you're going to get x minus 5 plus 2x equals 10. Carrie, if I told you you get x squared, you going to believe me?
No, not in this.
Not in this case? Okay. X squared. Damn. It's unbelievable. I just jacked that up and put a 3 in out of 2. 2x equals 10. X squared minus 3x equals 10. How do I solve that?
Well, what I did,
That, and then what'd you do?
And then I divided it by the x squared. So I divided
Oh,
by x.
no.
No.
Move the 10, set it equal to 0. X squared minus 3x minus 10 is equal to 0. Now you will factor, you'll get x minus 5. X plus 2 is equal to 0. Then you get two answers, right? X equals 5 and x equals negative 2. Does everybody agree with that? We straight?
X plus 10 plus 3x over x.
Small problem. Hercules was like, I got big problems. No, this is a small problem.
No, I didn't,
You remember what I just told you about the checking thing? What must you do? Plug in your answer, make sure you don't get 0, right? Plug in 5. 5 minus 5 is... So this answer does not work. The only answer you can go with, x equals negative 2. Okay, yes, sir.
So when it's a square, you just get the number right, set it to 0, and then factor it.
When it's a square, you set it equal to 0 and factor it, yes. At least for right now.
But you can't go any further than that.
Yeah, but if it's a square, Hercules, it's a very good point. When it's a square, get it set equal to 0 and factor.
Well, in all fairness, mine still works out. I just didn't get the x by itself.
In all fairness, you did it, but it was just wrong, yes.
Yeah.
Yes.
But it still plugs into the equation that I